Douglas Brenner Shocks here in Southern California. I'm authorized Ohlins sales and service for both automotive and motorcycle. I think I'm the only one in the country authorized to do that, and I'm exclusively Ohlins. I don't work on anything else. I'm a shock tech, not a guru. I've done this for over 30 years, and also I know it's hard to believe because I am so young and handsome. I've been racing for over 50 years and doing shocks and putting them in my car and seeing in competitive on-track situations what I've done. I'm not sitting on the internet or just on YouTube. I call them on the internet jabberwankers, telling you what to do when they have no real experience with actual racing or with real competitive drivers. So be careful. I also know I'm not going to be an internet sensation, so I make my money selling and servicing Ohlins products. So give me a call if you need service or sales. You might as well buy it from somebody who actually knows inside and out the product and not a internet reseller. I'm as close as UPS, FedEx, etc. If you need service or bring them over. I'm in Southern California. I'm available 7 days a week to serve your needs. So give me a call if you need something, and I can compete with any price on Ohlins products. Any legitimate price you have, I can do the same or better, and you might as well buy it from somebody who knows the product. So let's see what we have this week. Okay, this is my third series on valving, and we're going to learn a little more about shims. And I have Karloff here, my Frankenshock I made from parts I had laying around. It's a WCJ without a base valve. I'm going to put back the original shim stack that I had in the first video on this series, and we'll go from there. Okay, I've been dreading this because I'm such a terrible artist. And also I see so much misinformation on whiteboards. I hate whiteboards, but I'll see if I can make this a little clearer with this drawing. Clamping shim is really important, and some of the brands, which I'll show you in a minute, don't really have different clamping shims. So let me explain it. So here's your piston here. Here's the oil coming through the ports, and here's your sealing shim, and the oil pushes and the low pressure pulls. I'll go into that. But these shims start to move away. They're actually touching each other in most cases. So this shim starts moving away from the port, letting more oil go out. So this top shim is the clamping shim, and it's held next to this big thick shim. So when you tighten the nut down, this doesn't move. These shims all move. You can see this can move and this can move and so on, but this can't move. And also, if you draw a line directly down from the outside of that clamping shim, none of these shims move inside of this area. They all start bending right here. And as we know about leverage, the more leverage you have, the easier it is to move anything. So this port pushes here, and it has a certain amount of leverage on that shim. Now, if you put a different size clamping shim, let's say you put a smaller clamping shim, and now that little red line comes down inside here, well, there's more shim to bend. So therefore, this whole stack gets a little softer, a little less damping. It usually keeps the same characteristic. You've worked really hard to get this looking like you want on the dyno, but I want to leave the bleed open, and I want a little less damping, and I don't want enough less to change the shim stack down to the next smaller shim. So you go in and you put a little smaller clamping shim. And I'm going to show you this on the dyno. Same goes the other way. Let's say it's perfect, but you need a little more damping, and you don't want to close down those bleeds. The basic characteristic of the stack looks the same, but you can get a little more, a little less damping. It's really a neat little tuning item. But you want to make sure that, and I'll show you once we get off this drawing, usually the ports are in a little, but this is just a bad drawing. Wonder who did that. So anyway, this is a real important shim, and these so-called professional shocks, some of them only have one size, and that's that. Okay, here's a 44 millimeter piston, Ohlins, probably from a TT44 IndyCar shock from the 90s. Still a fantastic shock, but they don't make them anymore. Very complicated to work on, by the way. So if you want to use a clamping shim, you have to make sure this clamping shim isn't going into the port and leaving a little room, because this clamping shim is on top, but the sealing shim is bending from the edge of this. So you always want it bending over some metal, so you want to leave a little space here. You don't want it protruding into the port because it fatigues the shim, number one, and number two, the shim does not bend inside the port. It's bending out here, and you're not using all the port. The port's restricted. Ohlins has a 16 millimeter, which is the smallest shim, all the way out to this 23. Although if you're getting to the 23 millimeter, or you're getting out there, it might be time to go to a thicker shim stack, unless you already have the thick stack and you need to make a ton of damping, and you're kind of out of options. But at least it's an option. So one of my longtime racing pals was working on this vintage 60s road race car, and we couldn't find any Ohlins that would fit. So he was forced to go to this other so-called professional manufacturer and bought 4 shocks, and then sent them over to me to be dynoed, and they were awful. And I took it apart, and this is what was in them. This is their so-called high-flow piston. Now, this wasn't for any weird application. It was a road race application. I put their linear piston back in, and that was that. So I don't know why they would put this high-flow piston in anything. Probably it makes some sort of digressive damping. Maybe there's a reason for it. I don't know. But we're looking at the rebound side. There's a so-called other competitor to Ohlins that makes shocks for road racing motorcycles, among other things. And it's a single tube, old technology shock with lots of anodizing and knobs. And it sells for more than an Ohlins TTX36 GP with spring and hydraulic spring perch adjuster. And in their ad, they say, our shock flows 23.5% more than an Ohlins TTX. I can just see all the Ohlins engineers sitting around looking at each other going, why didn't we think of that? And I guess that's just marketing. It's not a cylinder head. It's a shock absorber. It's a damper. What is damping? What is what we're doing? What we do is the art of restricting flow. That's what damping is. And what you have in your palette, your brushes, your canvas are pistons, bleeds, and shims. And with those, you can paint whatever picture you want. So what they've done, instead of having ports that are out as far as you can get them, which is the way you want to design a piston. All good pistons, all Ohlins pistons have the ports out as far as they can, especially on the compression side. This is the rebound side, and they've just drilled the holes out, and you can see it's very thin in here. Why didn't they go out? So then, this particular shock, I think the Ohlins we have just in shims, just regular shims, not ring shims or slotted shims or any fancy shims. Just in basic shims, I think there's 25 different diameters in 6 thicknesses. So what's that, 150? This particular shock has 5 diameters in 6 thicknesses. That's 30. So you're really limited in what you can do. I didn't include what they call their constant shim, which would be a clamping shim in Ohlins, because they only have one of them, one size, 3/4 of an inch in diameter and 20 thousandths thick, and it's the only one they have. So when you put their clamping shim on this piston, it's protruding into the port. So not only aren't you getting the full flow of the port, but you're running the risk of cracking those shims because they're up in space. So here's an Ohlins piston, the 44 millimeter. It uses a 38 millimeter shim to seal on the compression side, 36 on the back side, and there's a reason for that we went through in my video on shock dyno basics. So here's 46 millimeter piston. Now this is only 2 millimeters bigger, yet Ohlins now uses a 40 millimeter sealing shim. You want those ports as far out as you can get it. All right, here we go. First I took all the shims off of the piston, stuck it back in the shock and ran the dyno, and here's what you get. Virtually no damping, a little bit, and this is gas pressure in the shock, and whatever forces are there are probably trying to put the rest of the piston that doesn't have holes through the oil, gives a little resistance. And you'd probably have to get way out in velocity to see this change at all. Those are the fixed ports. Okay, then here is our original damping, our original little shim stack 0.20. You can see it's pretty nice, in my opinion only. Not much hysteresis, very linear. With this particular shim stack, the clamping shim in compression was 20 millimeter, and the clamping shim in rebound was 22 millimeter, which is almost as big as you can go. So this is the most damping you could probably get with that stack by changing the clamping shim. And this one here, there's some way to go. It's not in the middle, it's on the high end of the middle. So what I'm going to do is I'm going to put a 23 millimeter clamping shim in compression, so we should see some increase in damping. And I'm going to put a 16 millimeter clamping shim in rebound. We should see the rebound go way down. So let's see. There you go. And this is just changing the clamping shim. Look at this value, it goes up. And we only changed 3 millimeters. This is kind of the maximum that you could do. And look at that, that's 30 pounds different just in changing the clamping shim. And then here, the rebound is a lot. The rebound, because we really changed it, goes from what's this, about 70 pounds to maybe 125. It's a little funky in here, and I think that's because we went from 26 millimeter shim to a 16 millimeter. That's 10 millimeters. So probably we could straighten this out and make it nice if we put, let's say, a 23 millimeter 0.20 shim in there, or something just to kind of smooth it out a little. But you can see the difference just from the clamping shim, and you don't see a lot more hysteresis or anything. It's really a handy item if you're valving and you need a little more force, but you don't want to mess up your stack. Okay, please subscribe, hit the bell. We'll continue on to part 4 of valving. We'll go into more minutia of valving. I hope this was informative on the clamping shims. I'm hard on other shocks, but I'm an Ohlins guy because Ohlins is the best, and I just don't feel like selling or working on anything else. And Ohlins is not the best just because I work on them. So I just want to make that clear. I'll see you hopefully next week with my next video. Thanks a whole bunch for watching.